So good afternoon all. We are starting the lecture number 65 for data structures and algorithm. Am I audible to all now?
Yes, sir.
Okay, so
Yes, sir.
we have looked at the graph and we have learned the very basic terms that we need to use in the graph in previous lectures. We have also seen the different kinds of the graphs in previous lectures. Now we are going to start the representation of graph. Okay, so let me allow to share my screen. Is it visible to all now?
Yes, sir.
So we are starting the representation of graph now. So as we have seen the representation of every data structures that we have learned till now, which includes stack, which includes queue, linked list, and tree. So can anybody tell me that how many different kinds of representations are there for a specific data structure?
Two types: linked representation or array representation.
Okay, any other answer?
So static representation and dynamic representation. Static
Okay,
includes array representation with the help of array, linear data structure, and dynamic uses linked representation.
okay, good. So both are correct. So static and dynamic, largely we can classify it as, but static using array and dynamic using linked list. So here same we will represent the graph using two different representation, that is sequential representation and linked representation. Okay, so that is nothing but again it is static and dynamic only. Okay, so statically in static representations we will use sequential representation. Sequential is nothing but an array, and dynamic representation definitely we are going to use linked list for the representation. Okay, now in the case of graph, now till now the data structure we have used, we have only one parameter to represent. Okay, and now in the graph we have two parameters, that are edges and vertices, because any graph, as we know that graph is a combination of vertices and, tell me, graph is a combination of vertices
Edges.
and edges.
Vertices and edges.
Okay, so graph, we are representing the graph as this way, V and E. So two objects are there actually. So the one is vertex and one is edge. So that's why we need two-dimensional array for the representation of graph. Till now we have used only one-dimensional array, as we have only one object, that is like we can say a specific value only. But now in this we are also having the edges to connect those particular values. So we use two-dimensional array. That's why I have written over there adjacency matrix and incidence matrix. So two different kinds of matrices are also in the case of static representation we will use. One is adjacency matrix and second one is incidence matrix. Okay. Now, second one is the dynamic representation, which will be used using linked representation, and it is again known as the adjacency list. So we are using the word adjacent over there multiple times. So first of all, look at what are actually the adjacency list. Okay, so we know that two types of the graphs we are having. One is directed graph and one is undirected graph. So for undirected graph, adjacent list could be like this actually. Okay, so graph is A, B, C, D, E, four vertices are there. Adjacency list will be a list of the vertices that are adjacent to a given vertex. I'm repeating, adjacency list will be a list of vertices that is adjacent to the given vertex. Like in this case, for A vertex, how many vertices are adjacent? Look at the graph only. Graph देख के बताइए. So three vertices are very good. Three vertices are there, and that are B, C, and A.
D.
And for B, it will be two vertices are adjacent, that are A and D.
And D.
For C, there are again two vertices, A and D. And for D, it is A, B, and C. Okay. So in this way, we can say that this is actually the adjacency list for the given graph when the graph is undirected. Is it okay to you all now? What is adjacency list? It will be helpful for us like when we are going to represent the graph, and also in the case of traversing of a graph actually. various operations we will also use this particular list. Now for directed graph, this is a directed graph now. For that, what we can use is we will use a term initial vertex and terminal vertex. So adjacency list will get changed now. You can see that. For A, which is the adjacent vertex right now?
C.
Only C is the adjacent vertex, because I can reach to C only from A. So that's why adjacency list will change in this case. So be careful when you are like designing or finding the adjacent vertices. In the case of directed graph, look at the graph. Graph are same now. Both the graph are same, but I have just put some directions in this second graph. So adjacency list will get changed. For A, C is the only vertices which is adjacent right now. And for B, same. In this case, only one vertex, that is A, is adjacent. Because we can reach to A by B only. And on C, if we will look at that, for C, as
There is no such vertex.
जीरो कुछ भी
zero,
नहीं है
because we cannot reach from C to any other vertex. And again, this kind of the vertex is also known as, can we tell me? C is also known as, because
Null.
it's,
Null, sir.
why it is null?
Isolated
Sir, that-
vertex.
No, isolated vertex, it means degree 0. It could be, we can say a degree is actually, the degree of C is now. Can anybody tell me the degree of C?
0.
Why 2? Why 0?
2 सर है एक तो इन डिग्री और एक आउट डिग्री
Both are actually,
C has 2 in degree.
C has 2 in degree actually. And out degree is
0.
0
0. So degree of C will be
2
how?
क्योंकि सर
हाँ बोलो.
क्योंकि सर सी में सी टू वर्टेक्स से कनेक्ट है ना ए एंड डी से.
Anyone else? Is C is connected to 2 vertices?
या फिर इसका उल्टा.
Sir, 2 vertices are connected to C.
So degree of C is actually what? 0 or 2?
2.
Why? You need to answer why also, okay? Not every time just like saying 2 or anyone else. 2, why 2? 0, then why is 0? We should also know why I am telling the answer 2 or 0. So you should give the reason also. Why it is 2?
Sir, we
Yes,
define a
certainly.
degree of sir, we define a degree of a vertex by the total of how much edges is connecting to the another edges and how much different vertex are connected to that particular edge.
Very good. So in short, I can say the degree of the vertex will be the sum of in degree and out degree.
And out degree, yes.
In
So
the
then
case,
for out degree it is 2. For in degree it is 2 and out degree is 0. And
the
total is 2.
total degree of the vertex is
2.
2, which is sum of in degree plus out degree. In the case of directed graph, I am saying only. In the case of undirected graph, definitely it will be calculated easily, because the total degree of A in the case of undirected graph, you can see, sorry, C, it is 2, because no direction is there, so it is only 2. The number of incidence vertices. We have we have used 3 days to learn the basic things, and still if you are not give the reason of your answers, then it is like not good for me. So I am repeating, in undirected graph, degree is the number of vertices incidenting on that particular vertex. In the case of directed graph, the degree of a vertex is the sum of in degree plus out degree. The 3 different terms are there: in degree, out degree, and degree. If I am talking about degree, then you have to give me the total degree of the vertex. Okay, now is it okay? Is it clear to all now? Say yes or no.
Yes, sir.
Okay, so for C it is 2 now. Degree is 2. In degree is 2. Out degree is 0. The total degree is 0 plus 2. Okay. But now in adjacency list, I will only take the vertex which are adjacent to that particular vertex. So adjacent means कि मैं उसका पड़ोसी हूँ, तो मैं उसका पड़ोसी कैसे हूँ? मैं उसके घर जा सकता हूँ. Okay. So क्या मैं C से किसी घर पे जा सकता हूँ यहाँ पर? A, B, D में
No,
से
sir.
नहीं जा सकता.
No,
नहीं तो
sir.
So for C it will be 0 now.
आउट डिग्री 0 है.
Adjacent vertex adjacent list जो है वो 0 हो जाएगी. So for C actually. And for D it will be
3. A, B, and C.
3. A, B, and C. Okay. Now C is also known as, like, let me tell you, you need to tell me actually. I have already tell you actually. So C is sink or source.
सिंक.
Sink.
And D is
सोर्स.
Source.
for source the in degree will be 0 and for sink the in out degree will be 0.
0.
है ना? So ये चीज हमें पता होनी चाहिए source and sink के accordingly हम बात करें. So this is what the how we can find the adjacency list of a graph, whether it is directed or undirected. Is it clear to all now? It will be used directly in my presentation now. Okay, in when we use adjacency list and in adjacency matrix and linked list representation. So I am coming on to the first one representation, that is adjacency matrix. For this is a kind of static representation. Okay. Now let GV be any graph with n vertices. Okay. The adjacency matrix of G keeps the information about the adjacent vertices, and in that we have only seen that what is adjacent vertices, how we calculate the adjacent vertices for directed and undirected both. That's why I have discussed this in the first slide only. Okay, so it keeps the information about the adjacent vertices only. How? कैसे करेगा वो हम देखते हैं now. Adjacent matrix say A of a graph G with n vertices is a n cross n matrix. It means कि n cross n क्या है यहाँ पर? Can anybody tell me?
टू
So
डायमेंशनल
n
मैट्रिक्स.
number of rows and n number of columns.
Very
Yes,
good.
sir.
So it is an order of the matrix actually.
टू
Okay.
डायमेंशनल
So
मैट्रिक्स.
matrix का order हमेशा हमें पता होना चाहिए. So it will represent the matrix order. It will be a kind of square matrix right now. So adjacency matrix first of all will be a square matrix and the order will be n cross n. If the vertices are 4, then it will be 4 by 4. If the vertices are 10, it will be 10 by 10. Matrix says that. अब कैसे उसमें entries क्या होंगी? It will be containing only 1 and 0 actually. You will see over there the entry Aij represents the ith row and jth column actually. You know that?
Yes, sir.
Do I explain this also? Aij. So Aij is means ki the ith row and jth column entry. Okay, it will be 1 if there is an edge between vi and vj vertex. Okay, and otherwise it will be 0. So it means if there is a vertex, sorry, if there is an edge between two vertices, the corresponding entry in the matrix will be 1, and if it is not, then it will be 0. Or we can say, like, if V and Vj are adjacent, it means they are connecting by an edge directly, then they are adjacent only, and in that case it will be 1, entry will be 1, and otherwise the entry will be 0. That is very simple how we will put the values. Now look at the example on that. Adjacency matrix. Okay, now first I will draw for you. So how many like what will be the size of this particular matrix, adjacency matrix for this graph?
4 into 4.
4 by 4.
4
4 by
crores.
4 का 4 by 4 का मैट्रिक्स होगा. ओके, एंड हम लोग क्या करने वाले हैं? We will put the like header of the row and column as A, B, C, D, and similarly for the rows it will be A, B, C, and D. Is it okay? So now what? How will be the entries? Can anybody explain? How
Sir,
will the
why we
entries
are
now?
taking 0?
For A,
only 0
for
and
this.
1?
Sir, 0, 1, 1, 1.
First question has been asked, like, why we are taking only 1 and 0. First thing is that it is by definition, and second one, it is we are representing the edges. We are trying to represent the graph with the help of a matrix. So we have choose that if there is an edge, then it will be 1, and then if there is a there will not be any edge, then it is 0. 1 and 0 is there. Why? Because in computer 1 and 0 has specific meaning. It can be easily
Boolean.
recognized by the machine also.
Boolean.
It is also this kind of the matrix is also known as bit matrix. Actually, the matrix containing only 0 and 1 is known as bit matrix, because we know that in computer we can represent anything with the help of 1 and 0 very easily. Is it so or not?
Yes, sir.
Everything, every number
Binary
or
bits.
every
Yes, sir.
so that is one of the reasons that we are using 1 and 0 in this representation. Okay, so now the values of the matrix will be how? A and A. Okay, so is there any edge between A and A? No, so it will be 0.
No, sir.
Is there any edge between A and B?
0.
Is there any edge
Yes,
between
1.
One.
Yes.
One.
Is there any edge between A and C?
Yes, sir. Yes, sir.
Yes, sir.
Is there any edge between A and D?
1.
And so on. So
One.
in this way, actually,
Yes,
in
sir.
this way, we will proceed and we will make a matrix, adjacency matrix. Is it okay now? So this will be the final matrix for you. Directly, I need to show it. Is it okay?
Yes, sir.
So let me push this matrix a little bit lower, so that whatever we are writing, it will be visible to you in the slides also. So this will be the final matrix for me. Now any doubt you can ask. Like C and B, there is no edge, so it is 0. Okay, C and B, there is no edge actually. Okay, and B and C, similarly, there is no edge. And also, if there is no loop, then diagonal entries are also 0. Now suppose I will have any loop over there. Say there is a loop in between A to A. So which entry will become 1 also in this?
A to A.
A
One.
A to
A
A.
1
Sir,
1.
first.
to A.
This one will
Okay,
become
okay.
the 1 also in that case. In the case of loop only. So is it okay how we are creating this adjacency matrix?
Yes, sir.
Yes,
Now we
sir.
will see some of the observation of this matrix. Okay, let us take one more example for you all. Now in the case of direction, how it will be? I have made two graphs, same
A
graph,
to A,
and
0.
one is directed and one is undirected. So we are now going to fill this particular matrix. So
0. A to A, 0.
So first of all, we are coming onto this undirected graph. Okay. So tell me the values for A to A, it is
0. 0.
0.
Okay. Now someone else tell me. Not every time, not the single person. Someone else who is ready to give me the answer. जो regularly नहीं बोलते हैं उनके अलावा हम बात कर रहे हैं. Or I need to choose one. Can anybody else? It is very easy actually. Voluntarily you can choose. Chitransha, Chestha, Chetan, anyone. I need to also see बहुत टाइम हो गया हम देखे भाई कौन कौन आता है कौन कौन बैठा रहता है कौन कौन सोता है. गरिमा, Gaurav, Gautam, Harsh. Anyone of you? Gautam, good. Gautam, are you listening us? Gautam, so can you tell us what could be the entries for this? You need to on your mic. Your mic is on. You can speak now. माइक ऑन है और आपके पीछे से आवाजें भी आ रही हैं. इसका मतलब आप बोलोगे तो हमें सुनाई देगा. Yes, Gautam. Or you are not able. I need to write the roll numbers also so that कभी कभी तो इनको भी जो unnecessarily बैठे हैं उनको हमको हैंडल करना चाहिए. So tell me, last 4 students are not responding. Harsh, Gautam, Gaurav, Garima. Okay, Chitransha, Chetan, Cheshta. Any one of you? So, Chitransha, can you tell us the entries here? Anyone else? Atishay, Bhavishya.
Yes, sir.
Atishay, you tell me. Tell us, beta. What will be the entries over there? I need to
A
write
to
the
B,
name.
sir, one.
Cheshta. Sorry, A to B is it is 1. Very good.
A to C, 1.
1. बोलते जाइए आप फटाफट रो वाइज.
A to D, 1.
Very good. A to E.
0.
0. Good. B to A.
B to A, 1.
1. B to B.
0.
0.
B to C, 1.
1.
0.
0.
1.
Very good. Then
C to A, 1.
you just like look at fast now. देखो मैं बताता हूँ तरीका बताता हूँ आप लोगों को. Look at the graph. From C we can reachable to every 4 vertices. है ना? A, B, D, E. हम चारों पे जा रहे हैं तो हम चारों के लिए 1 लिख देते हैं यहाँ पर. A, B, C पे नहीं जाएंगे, D और E. Okay. Now for D, how many vertices you can cover from that directly? A, C, E. Yes or no?
Yes,
So
sir.
it is A, C, and E. That's is 0. Okay. So now tell me. For last E.
B, C, D will be 1.
So there is not a loop in D to D.
There is a loop.
तो 1 होगा ना एंट्री.
Very good. So E to A.
1. E
Very
to
good.
0.
E to A 0.
अतिशय बोल रहे हैं क्या बेटा ये? अतिशय की आवाज बहुत तेज कैसे हुई? किसने बोला? कोई दिक्कत नहीं है, आप बताएं कौन बोल रहे हैं? Everyone needs to speak.
सर मैंने बोल दिया था.
हाँ बेटा, आप अतिशय हैं क्या? जो भी है, मुझे
नहीं
पता
सर,
नहीं कौन है.
गलती से हो गया था सर.
हाँ जी. E to B.
1.
1.
E to C, 1. 1. 0.
0. Is it okay to all now? Anyone wants to change it? Is it okay to all? अब तो सब बोल सकते हैं.
सर दिखाना सर एक बार.
Archie, are you there? Archie, Anshul, Raghav, Anirudh, Anamika, Amit Sharma, Amit Kumar, Aman Parekh. No one is there, na? I have attendance with me also. Aman, Amit, Amit Sharma, Anamika, Anirudh, अंशुल तो है. गुड. एनीवन एल्स? अदिति अग्रवाल, अदिति बंसल, वेरी गुड. चलो. Now can anybody tell me for the directed graph?
Yes sir.
कौन बताएगा? बताएं. हाँ,
A to
दक्ष.
A 0.
दक्ष वेरी गुड. दक्ष बताइए. दक्ष
0.
दक्ष 0.
A
वेरी
to
गुड.
A for 0. 0.
0.
1 1.
1. Very good.
0.
0.
And again 0.
0. Very good. For B.
For 1.
1,
0,
0,
0, and for D 0, for E 0, for C 0, for B it's 1, 0, 1, and for E 1. For D is 1, 0, 0, 1, 0, 0, 1, 0. For B, sir, B for 1, 1, and 0.
Good. It is okay?
Yes, sir.
Good.
Yes sir, it is okay. एक मिनट सर और देखने दो.
Now we are coming on to the properties of the adjacency matrix. Okay, you just look at that and try to find out some observation from that. Okay. So first tell me, is the matrix is symmetric in which case? Directed or undirected? With respect to the diagonal.
Symmetric, diagonal or
When the matrix is symmetric with respect to diagonal, in case of directed graph or undirected graph?
sir, both graph are conclude.
आपको पता है बेटा
Symmetric.
सिमेट्रिक क्या होती है?
Yes, diagonal matrix are contain 0.
Sir, in undirected graph it is symmetric.
Very good. Now tell the definition of symmetric. किसने बताया बेटा अभी?
Sir, Anshul Chaudhary.
Anshul, you just tell us the definition of symmetric. Because
Sir,
we do
sir,
some.
when we do the transpose of the matrix, then it becomes the original matrix.
Very good. It means that transform and the original matrix are same.
Yes, sir.
A is equals to AT transpose.
Yes, sir.
So that matrix is second matrix that we are having for undirected graph. I am talking about this one below matrix. It is symmetric about the diagonal. Okay, I was not asking about the diagonal matrix. I was asking about the symmetric matrix about the diagonal one. So ये देखो symmetric कैसे है? Zero diagonal में जो भी values है उसको छोड़ दो. उसके अलावा जो भी values हैं वो symmetric है. मतलब आप इसकी mirror image बना सकते हो. यदि आप diagonal पे एक mirror रखोगे तो दोनों तरफ सेम वैल्यूज दिख रही हैं आपको. मिरर इमेज है मतलब. ओके, बट इन द केस ऑफ डायरेक्टेड इट इज नॉट सो. डायरेक्टेड ग्राफ के केस में वो सिमेट्रिक नहीं बनेगी मैट्रिक्स. ओके, नाउ लेट अस लुक एट द वैल्यूज ऑफ द रो. द अनडायरेक्टेड के केस में देखिएगा, लुक एट द वैल्यूज ऑफ रो फॉर ए वर्टेक्स. ओके,
0 1 1 1 1 1 0.
मैंने ये बोला नहीं कि आप बोलो. There is an option in my class also that I can remove the persons from the class. Actually, I don't want to remove someone. Don't force me to do this. So look at that only. So what is the sum? अब मैं क्वेश्चन पूछ रहा हूँ तब आप बोल सकते हैं. Now look at that. What is the sum of that values? Row sums. I am talking about the row number A. The sum of the values will be
3.
And now tell me the degree of A in this graph.
3.
3. So what is the meaning of that? The row values will be, sum of the row values will be the degree of A. Similarly, degree of B is 3, sorry. Some degree of C is 4. You can check the graph also. I am talking about undirected graph. Right now I am talking about undirected graph. Is it okay? Degree of E is 3. Degree of D is 4. Is it okay to all?
Yes, sir.
Okay, now look at the directed graph. It is also true in the case of directed graph. Look
Yes,
at
sir.
the degree, look at that row. Total of row is 1. So it is representing what? The out degree. It is
Out degree.
representing the out degree. For the sum of rows representing out degrees actually, and sum of column representing in degree. Yes or no? It is true in
Yes.
this
Yes,
case.
sir.
Okay, so for the directed graph, the sum of rows will be in degree for a vertex 1, and the sum of columns will be the out degree of the vertex, that is 2 for A in this case. And you can cross check it for all the vertices. Is
In
it
degree for A
okay?
is 2, sir. In degree for A is 2.
Yes, in degree. Sorry, I just like, so row is actually out degree. मैंने यही बोला था
Yes,
पहले,
sir. Row is out degree.
है ना?
Yes.
मैं पहले ही बोला था, अभी लास्ट में तो इन डिग्री जो है, like column is in degree.
Yes, sir.
Some of the column is in degree and some of the row is out degree. And in this case, you can observe that sum of the row is equals to sum of the column because it is symmetric matrix.
Yes, sir.
हमेशा यही होगा क्योंकि इसकी इन डिग्री भी 3 है, आउट डिग्री भी 3 है. In the case of undirected graph, ऐसा है? Yes or no?
Yes, sir.
Yes, sir.
है ना? 9 4. Now you can cross check also for D. So we are now trying to conclude the things that we have studied. I have written in the slides also. The adjacency matrix for an undirected graph is symmetric. It is true. The adjacency matrix for the digraph need not to be symmetric. What is digraph? Actually, it's a short form of directed graph. The adjacency matrix for a directed graph need not to be symmetric. जो हमने अभी discuss किया. Now, number of ones in the matrix is the number of edges in the graph. Again, it has been like find out the total number of ones. It will be the total number of edges in the graph. In directed case, I am talking about. Is it so?
Yes, sir.
Yes. But in the case of undirected, what it will be?
Twice of 1.
Twice of
Sorry.
that. Yeah. Twice है या नहीं है?
Sir, in case of undirected graph, it is the number of ones, the number of edges.
No, in case of directed graph, it is number of ones, which is equals to the number of edges.
Sir, on the vertex A, 3 edges are inclined, and same is the number of ones in the first row.
You are talking about directed or indirected?
Undirected.
Yes.
Sir, so the number of edges falling on A is 3, and similarly, the number of ones in the first row is 3. So
Yes.
they both are equal.
Yes. Where is the confusion now?
Sir, अभी जो आपने बोला वो उससे confusion है.
It is number of ones in the matrix, number of edges in the graph. It is for directed only.
And sir, I am talking about the undirected.
No. It is not for undirected actually. Number of ones in the matrix, number of edges in the graph. It is for digraph. Now is it okay?
Sir, undirected में भी तो same हो रहे हैं.
नहीं बेटा, number of ones in a matrix. You just read the number of ones in a matrix. इस पूरी matrix में कितने number of ones हैं?
Sir, we are talking about the whole matrix and not the
Matrix.
single rows.
Read the line. Number of ones in the matrix.
Okay. ठीक है sir.
है ना? Now look at that. यहाँ पर
Sir?
कितनी indirect? Let me
Sir?
one. Yes.
So if we have an diagonal of ones, only just we say if we have a diagonal of ones, then there only be the loop in our graph only. Then we'll have only loops of graph.
I will come on to that also. You are
Okay,
right
sir.
now. You are right. है ना? So number of ones in the matrix, number of edges in the graph. It is for directed graph. Now for undirected graph, you just count the number of ones and number of edges. Number of edges are
Twice of number 1.
3.
सर ट्वाइस से एक कम 2n minus 1.
actually total number of ones are 17. You just count it.
Yes, sir.
Yes, sir. And the edges are
and
9.
edges are 9.
9.
And we have
9
seen the
edges.
formula also that number of edges will be twice actually. Now what happens here? यहाँ पर जो loop है वो एक ही बार लिखा गया है actually. इसलिए एक नंबर कम आ रहा है. बट हम वहां जब डिग्री काउंट करते थे तो उसमें काउंट करते थे ग्राफ में तब हमको पता था कि वो डबल है.
Yeah, for in order and in degree and out.
For in degree and out degree 1.
So that is what the reason is there. So that's why I am not saying कि वो formula यहाँ true हो रहा है. I'm just like we are just discussing the thing, but it is not so actually. But it is only true for directed graph. What I am saying is, number of ones in the matrix will be equal to the number of edges in the graph. Okay. Now, in number in each row shows the out degree of each vertex. Definitely, it is for directed graph because out degree I am talking about. Number of each numbers in the each column shows in degree of the each vertex. We have seen already. Okay. Is it okay? This fourth and fifth point is okay.
Yes, sir.
And the total of this will be the out degree and the in degree actually. Now, for a null graph, all the vertices, all the values of the adjacency matrix are 0. Is it clear? Null graph means there is no edge.
Yes, sir. There is no
edge-
edge.
Only vertices.
Yes, so edge ही नहीं होगी तो यहाँ पर कोई edge ही नहीं, कोई one ही नहीं होगा overall actually. So it will be a zero matrix actually. Zero matrix, you know what is a zero matrix?
Yes, sir. In which all the terms
All
are
the
0.
values are zero actually. Now, for a weighted graph, the elements of the adjacency matrix are the weights on that edge. Now, what does it mean? It means कि suppose I am putting 12 over there. So the edge from D to A, it means D to A, it will be 12. It will not be 1 now. Is it okay?
Yes, sir.
So in this is only when
Sir, what's
when
12 is representing over here?
it a weight. It is
Weight.
a weight. It is a weight, and it could be representing
means
like it could be
Any
representing,
unit between D to A.
Yes. Okay, it is as per the question given to us. Whatever given to us, it will be representing that thing. So now, is it okay till that point for a weighted graph?
Sir, can you, sir,
Ah.
I was not understand that. Can you tell me what to do, sir?
What you want actually?
सर जो आप इनसे डिस्कशन कर रहे थे वो मुझे समझ में नहीं आया सर.
मैंने तो कुछ डिस्कशन नहीं किया बेटा, मैंने तो ये पॉइंट्स पढ़े हैं बस.
नहीं सर, ये नंबर ऑफ वंस मैट्रिक्स इक्वल्स टू ये आप समझा रहे थे ना, मुझे नहीं समझ में आया सर. ये
नंबर ऑफ वंस कितने हैं इस मैट्रिक्स में, काउंट करो एक बार.
मैट्रिक्स में
मैट्रिक्स पता क्या होती है आपको?
यस सर.
तो हाउ मेनी नंबर ऑफ वंस आर देयर इन दिस मैट्रिक्स?
17.
I am talking about the upper one, directed graph.
डायरेक्टेड ग्राफ. 9.
9. and नंबर ऑफ एजेस कितनी है डायरेक्टेड ग्राफ में? This is 9 also.
Nine.
So that is what
9.
I am telling. That is what I am telling. Ki number of 1 equals to number of edges in graph. It is written very clearly on this. Number of 1 is equals to number of edges in a graph. That is all. ये लिखा हुआ है साफ साफ बच्चे, यही डिस्कस कर रहे थे हम लोग. एंड देन उसके बाद हम बोल रहे हैं कि नंबर ऑफ, ये जो मैंने यहाँ डिस्कस किया, नंबर ऑफ 1 इन द रो विल बी आउट डिग्री, नंबर ऑफ 1 in the column will be in degree. Okay, so like suppose
number of rows represent the out degree and number of columns represent the in degree.
Yes. Okay. Now tell me. Suppose this abhi some student has raised the question. Suppose I am having a graph with only loops. Then in that case, which kind of the matrix I will get? Suppose I am having this graph A, B, C, and I am having a loop over there only on all the three vertices. So which kind of the graph I will get?
Diagonal matrix.
Diagonal graph.
Diagonal matrix.
Identity matrix, sir. Diagonal identity matrix.
Identity.
Identity
1 1
matrix.
1.
In which all the diagonal
All the
values will be
diagonal
1.
elements will be
Diagonal
1.
matrix are
Rest all
1.
0.
Now coming on to the matrix. So incidence matrix is now, as it adjacency matrix, we have seen we have tried to find out the adjacent of the particular vertex. Adjacent, it means पड़ोसी identify कर रहे थे उसके अंदर. Now in this, what we will do, we will try to find out the incidence of an edge. कि कोई एक edge किस vertex पर गिर रही है, या इसको vice versa भी ले सकते हैं कि किस vertex पर कौन सी edge incident हो रही है. Okay, so this matrix will be a relationship between the vertex and edges, not only in the vertices only. In adjacency matrix, we have seen the like which vertex is adjacent to one vertex. So that's why we have find the relationship between vertex and vertex only. That's why
हेलो
the
सर.
hello.
सर एक बार ये आप 5th पॉइंट उसका रिपीट करना, वेट वाला एजेंसी मैट्रिक्स का.
किस कौन सा पॉइंट बजाय बताइए.
ये सर फॉर ए वेटेड ग्राफ द एलिमेंट ऑफ एजेंसी मैट्रिक्स आर द वेटेड ऑन द दैट एज.
So here I have shown the example also. Suppose like till now I have not given any kind of weight on the graph. जो मेरे पास ग्राफ था वहाँ कोई वेट नहीं है बेटा. वेट मतलब एजेस पर कोई भी वैल्यू नहीं लिखी हुई है. Okay, then I am using 1 and 0. Otherwise, suppose I have been given 12 on the edge number AD. So the value from D to A will be 12 now. D to A, why D to A? Because from this edge is from D to A actually. Direction देखेंगे आप. Okay. So यहाँ पर मैं 12 put करूँगा.
सर फिर इसकी इनडायरेक्ट डिग्री 2 ही रहेगी या फिर 12 के कारण चेंज होएगा?
नहीं, it will be the total number of ones. I am saying number. Look, अब आप इसको गिन लोगे कितनी वैल्यूज आ रही है इसमें.
Okay sir.
It will not be 13. Definitely it will not be 13. Very good. आपका अच्छा observation है आपका. It will not be 13. It will be only 2. We will count the total number of non-zero values in that case.
Okay sir.
Very good. Okay. Anything else? So incidence matrix will be the relationship between vertex and edges, and that's why the incidence matrix of G with respect to the listing above that we have done above. Like suppose, let me first read the first statement. Let G be undirected graph, and V cardinality of V is n. It means total n vertices are there and total e edges are there. Suppose, and we suppose that the vertices and edges of the graph are listed in an arbitrary order as V1 to Vn and E1 to Em respectively. Okay. Now the incidence matrix of the graph with respect to the above listing will be a non-zero. Will be a matrix of the order n cross E. Order क्या है यहाँ पर? Please look at that order. Order is n cross E now. So it is a relationship between the edges and vertices both. In adjacency matrix we have seen it was n cross n. Okay, 0 1 matrix again. 0 1 matrix means कि it will again contain 0 and 1 with 1 as its like कैसे होगा ये हम देख लेते हैं. If suppose I am saying कि I is the incidence matrix. Okay, I is this incidence matrix and I of ij will be 1 if the edge ej is incidenting on the vertex vi. Look at the order only. So ej is incidenting with the vi. So I is here representing what? Rows or column?
Rows.
And J is representing what?
Column.
Column. So जो मेरी मैट्रिक्स बनेगी उसमें भी ये चीज होगी. E will be on the column and V will be on the rows. Vertices होंगे कहाँ होंगे? वो rows में होंगे. Okay, and if an edge is incidenting on the specific vertex, then we will put 1, otherwise we will put 0. Now look at the example. With the help of that, you will be easy to understand. Now, what is the incidence matrix M for the following graph G based on the order of the vertices? Orders दे रखे हैं ABCD, vertices sorry ABCD हैं, and the edges are represented by 1, 2, 3, 4, 5, 6. Now look at that. These are not the weights. ये चीज भी ध्यान रखिएगा. These are not the weights. These are only the values that are representing the edges. It is look like E1, E2, E3, E4, E5, E6. Is it clear now? Do not consider that value as a weight. These are numbering of the edges. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Now look at how we will draw the incidence matrix. Look at that. Okay. So how many vertices we have?
4.
And how many edges we have?
6.
6.
So what will be the order of the incidence matrix?
6 by 4.
4 by 6.
4 by 6. 4 by 6. It will be n cross E. So it is 4 by 6. First of all, is it okay? Now it will not be a necessarily a square matrix. जरूरी नहीं कि square matrix हो. Okay, but in the case of adjacency, it must be a square matrix. Now हम ऊपर तो यहाँ 1, 2, 3, 4, 5, 6 लिख लेंगे because columns are representing the edges and the rows are representing the vertices. So यहाँ पर हम A, B, C and D यहाँ लिख लेंगे. Is it okay? Now tell me, is 1 is incidenting on A? Edge 1 is incidenting on the vertex A or not?
Yes.
Yes.
Yes, sir.
Yes.
So value is 1. Is 2 is incidenting on A?
Yes.
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 3?
Yes.
No.
It
No.
will be 0. It will be 0 now. 4,
No.
5 and 6?
5. Yes. 6.
Yes. 6. No.
In this way, we will create a matrix. Is it okay to all now?
Yes, sir. Okay.
For C, look at that. C, loop is there. So C पर कौन सी values 1 होंगी?
4, 5 and
4,
6.
5, 6.
6.
4, 5, 6.
4
4,
or
5.
5.
Good, है ना? So look at that matrix that we have actually. That is actually the complete matrix we have with us. And look at that and observe that. If you have any doubt, then you can ask.
So what if it is a directed graph?
I will come on to that also. First,
Okay.
clear the basic of undirected graph. Is it okay now? Is there any doubt? You just cross check the entries. If you have any doubt, you can ask. For D, the value of 2, 3, 4 will be 1. For C, the values for 4, 5, 6 will be 1. For B, it will be 1 and 3 only. All others are 0. For A, it is 1, 2 and 3. Sorry, 5. So is it okay?
Yes.
So what does it mean actually? Suppose the entry that 3, 1 is 0. Say this entry 3, 1. So what do you mean by that 1? We can say that the edge 3 is incidenting on the vertex B. That's why the entry is 1. Is it okay? Now coming on to the directed graph. Now just
Sir?
Yes.
So here we are defining order as n by m or m by n.
N by E.
And n is the number of
And is
vertices.
the
Number
So
of
E
vertices,
is the vertex.
number of
So
edges.
so why we are not
Then why it is 4 by 6?
using
It
B
should
into
be
E?
6 by 4.
Oh, number of vertices are, how many number of vertices are there?
4.
4.
And how many edges are there?
6.
6.
So it should be 4 by 6 now. Look at that matrix also. The order of this matrix is what?
4 by 6.
4/6.
4 रो हैं और 6 कॉलम है.
Sir, why don't we directly write E cross E?
Why we should write beta? Because we want to find out the relationship between vertex and edges, both.
Edges.
We should have both actually in my matrix.
Yes, sir.
So-
That's why we are writing the N cross N by E. Then why can't we write just V by E?
We are writing N cross E.
Yes, sir.
We are writing N cross E. So you are saying why we are not writing E cross E?
V cross E because N is the number of vertices only.
It's a V cross E. This is just a notation. You can use V also. I don't have any issue.
Okay, sir. Okay.
Yeah, because I have taken N over there. Number of vertices as N. मैंने यहाँ लिया था इसलिए मैंने इसको E लिखा है.
Okay, sir. Okay. Okay. Got
It's just a notation. You can take V, you can take S, you can take A, whatever you want. Just a notation. But just remember the concept only. The thing is that. Okay, now what should be the case of undirected graph? Just look at that. Suppose I have an direction from A to B. So now tell me what you will say. One is incidenting on B or one is incidenting on A, or
one is incidenting on.
One is incidenting on B.
One is incident of B.
Is it okay to all now? How it will be now for the directed graph?
It is okay, sir.
So for directed graph, the incidence will be look like this. If the direction is from A to B, then we can say that edge 1 is incidenting on B only. It is not incidenting on A actually. So the value from A to B is for the value 1 to B is 1. And what about the value for 1 to A?
0.
No, it is not 0 actually.
0.
Now there are two different representation of incidence matrix for directed graph. Okay, one, we can use the same that we are using, the following the rule. If the edge is incidenting, we are putting 1, otherwise it is 0. But in most of the cases, the matrix will change actually. It will also include -1 entry. -1 is for the value, say E3. Now look at that graph actually. E3 is incoming to A, so it will be -1. Okay, it is incidenting, so we are representing it -1. But if it is it is outgoing, let us say for E1 to A, it is 1. For outgoing, it will be 1, and for incoming, it will be 0. Oh, sorry, -1. Let me write over there. For outgoing, it will be 1. For incoming, it will be -1, and otherwise it will be 0. So this is one of the representation of incident matrix also कि इसमें हमने in degree और out degree दोनों को ही use किया है.
So then which method we have to follow?
हाँ, we have to follow this one. I have used this matrix for you for your reference so that like कुछ बुक्स में आपको ये भी मिलेगा. अपर लेवल पे हम -1 भी इंक्लूड करते हैं. ठीक है, but for the time being you have to follow this matrix only.
Okay. So till now we have studied only incidence matrix. So
Yes.
Is there any means for out order also?
आउट ऑर्डर के लिए ही बताया ना बच्चे मैंने. देखो ये जैसे हमने अभी इसको
Okay, we just change the term -1, 1 and 0 for out order and in order. Okay.
Yes.
सर एक बात पूछनी थी.
पूछो.
सर आपने यहाँ पर इन आउटडोर ऑर्डर को इस मैट्रिक्स में 1 से रिप्रेजेंट किया जाती और इन ऑर्डर को -1 से और 0 को नो रिलेशनशिप बिटवीन.
Yes. Like E1 C is 0 because E1 is not touching C. E1 touch नहीं कर रहा है C को. ठीक है?
ओके सर.
But now tell me, suppose कॉपी में करता हूँ इसकी डुप्लीकेट बनाता हूँ. डुप्लीकेशन ये प्रॉब्लम हो जाती है कि सब चीजें आ जाती हैं. तो अब मैं मान लीजिए कि इसमें डायरेक्शन देंगे तो ये चेंज हो जाएगा एक्चुअली इंसिडेंस मैट्रिक्स के अकॉर्डिंग. I will give the example over, okay, and then you will do it on your own. आपके ऊपर छोड़ता हूँ मैं एग्जांपल दूंगा मैं आपको. So is it okay now for incidence matrix? Any doubt till now?
No, sir.
Yes, sir, it is okay.
Sir, in director graph, if we make that matrix and if we use a parallel edges, then also we will include one only in the block of matrix.
Please repeat your question.
Sir, if in the director graph, if we use parallel edges and we make the
Yes.
matrix, then also we will include one in the box, or we will use something extra or something else.
So you are talking about some parallel edges, like suppose I am having this one more edge over there.
And sir, one thing also, if we are using parallel edges, then there is already a connection. Then why we are making another connection in the same direction only?
एक तरीके से आपने अपने क्वेश्चन का जवाब दे दिया बेटा, है ना? Like right now we are learning for simple graphs only. This is what the representation of the simple graph. We are not trying to use for the parallel edges. Parallel edges का क्वेश्चन अच्छा है. मैं एक बार देख के बताऊंगा आपको कि पैरेलल एजेस के लिए हम मल्टीपल एंट्रीज तो डेफिनेटली नहीं होंगी. क्या होगा मैं एक बार देखूंगा फिर मैं आपको बताऊंगा इसके बारे में.
सर वही करेंगे ना पैरेलल में. सर डायरेक्शन तो एक ही होगा ना.
डायरेक्शन तो एक ही है, लेकिन ही इज सेइंग कि सपोज दो एजेस हैं यहाँ पर, तो उन दोनों के लिए एंट्रीज अलग अलग होंगी या नहीं होंगी. आप यही बोल रहे हो ना बेटा अजय?
Yes sir, that's what I'm saying.
A to B, suppose I am having parallel edges, so what will be the entry for A to B in this value, in this
And why
matrix?
we are drawing, and why we are drawing A to B once again?
See, it could be there because there could be a multiple path or multiple ways to reach over there.
Yes. Okay, got it, sir. Got it. That's.
हो तो सकता है, लेकिन इसका आउटपुट क्या होगा ये मैं देखेंगे एक बार.
सर यहाँ पर तो चलो आपने पैरेलल एज एक लिए हैं. अगर मल्टीपल है पैरेलल एजेस हो तो फिर क्या इसमें मल्टीपल मैट्रिक्स कर लेंगे और डायरेक्शन तो सेम ही है ना सबकी.
मैं एक बार इसको देखूंगा फिर मैं बताऊंगा आपको कि पैरेलल एजेस
Sir, in this
कैसे
case, we can increase the number of ones if we are considering 0 and 1 as a bit.
सॉरी वापस बोलिए बेटा, एक बार रिपीट योरसेल्फ.
In this case, for a parallel edge, we can increase the number of ones.
We can increase the number of ones, like
Because you have said these are beats, 0 and 1, those are beats.
bits values.
So we can increase the number of ones.
Okay,
Suppose
now
there
you
are
are saying
two.
2 1 हो जाएंगे यहाँ पर, 3 1 हो
Yes.
जाएंगे ऐसा.
Yes.
Okay, actually I am not confirm on that. I need to look at that. एक बार
Sir,
मुझे देखना
direct-
पड़ेगा.
एन पैरेलल एज हो तो क्या n1 लगाएंगे.
And sir, if we give a weight to that parallel edges, then also we will give 1 1 only, or the value of that weight.
अब ये सब assumption है बेटा. एक बार मुझे इसमें मैं देखूंगा फिर I will come back to you actually.
सर दोनों के लिए चेक कर लेना डायरेक्ट और इनडायरेक्ट.
हाँ जी बच्चे, गुड. वो तो मैं डेफिनेटली दोनों के लिए करूंगा, है ना. एंड आई आस्क आल्सो यू टू सर्च ऑन दैट. देखते हैं हमें किसको, मतलब किसी को कुछ समझ में आया तो वो भी हमसे शेयर कर सकते हैं. ओके, आई एम नॉट सेइंग कि यहाँ पर मल्टीपल वन लगा रहे हैं, ये वी आर जस्ट डिस्कसिंग इट. ओके, आई एम नॉट सेइंग, प्लीज जो समझ रहे हैं कि हमें मल्टीपल वन लगा रहे हैं, और प्लीज इसको ऐसा मत लें. दिस इज फॉर जस्ट आवर डिस्कशन. वी विल, I am coming back. I will come back onto that actually. कहीं इसको देख करके समझें कि हम डबल वन लगा रहे हैं. So it is not so. So this is what about the simple static representation we can say for a graph. We have learned 2 representation. One is adjacency matrix, that is the relationship between the vertices only, and that's why it is n cross n matrix. And second one was incidence matrix, that is a relationship between vertex and edges, and that is why it was n cross e order. So now we will learn about the linked representation in next class. Is it okay? Till then, any doubt you can ask. We will learn about the linked list representation, that is adjacency list, in the next class, as it is already 2:40. So I think we should stop now. If you have any question, you can ask. I am going to take attendance. So is there any question, or otherwise I am going to stop?
सर इससे रिलेटेड नहीं है सर.
Related to that, I am asking only. So thank you very much. In next class, we will learn about the another representation of the graph, that is linked list, and we will also try to start the operations on graph. That is, first of all, we will start with traversing of the graph. हम traverse कैसे करेंगे graph? Like we have done for the tree in order, pre-order, and post-order. How it will be for the graph, we will see, and in the next class. Okay. So thank you very much for now for this class.